Hey guys, Mr. B here, and in this video we're going to be going through the practice problems in chapter 8.1 on molecular compounds. So here, beginning with number 1, it says classify each of the following as an atom or a molecule. So from the chapter, we need to remember that molecules or molecular compounds are where we have two elements that are nonmetals and they are bonded together. So in the first one, letter A, we just have beryllium. And beryllium is an atom. And beryllium is an element, and elements by themselves typically are atoms. Now, there's only one beryllium atom, 2 here, so this even more goes to show that this is an atom, not a molecule, because in order to have a molecule, you need to have at least 2 atoms or more that are bonded together, and this is just one beryllium. So this is going to be an atom. Letter B, we have CO2. All right, so here we have more than one element, and we have primarily, and the main important part is we have more than one atom. Okay, we have a carbon atom, okay, that's what the 1C means, and we have 2 oxygen atoms. So total, we have 3 atoms together, and they are nonmetals. They're bonded in a compound, which would make this a molecular compound or a molecule because they are 2 nonmetals, and there's more than one atom of each of them. And then as for N2, N2 is nitrogen, okay? So it's the same element, but there are 2 nitrogen atoms that are bonded together. Nitrogen being a nonmetal, and they are bonded together would make this a molecule, okay? So you don't have to have more than one element, but you need to have more than one atom, and those atoms need to be of elements that are nonmetals. They have to be bonded together, okay? So hopefully that makes sense, but if you have questions more on that, ask me about it. All right, number 2, which of the following are diatomic molecules? So the word diatomic means that we have 2 atoms exactly, okay? So CO2, we have 1 carbon, 2 oxygen atoms. That's 3 atoms total. So that is not going to be diatomic. That will be triatomic, tri for 3, like a triangle has 3 sides, or a tricycle has 3 wheels. So this is not diatomic. It would be triatomic. Letter B, we have O2. All right, so we have oxygen, but we have 2 oxygens. So because we have 2, this would be diatomic, because again, diatomic means 2. And although it's the same element, we have 2 atoms, okay? Diatomic. Di meaning 2, atomic meaning atom. So 2 atoms. So that is diatomic. And then letter C, H2O. We have 3 atoms total. We have 2 hydrogens, 1 oxygen. That is 3 total atoms. That would be triatomic, not diatomic. So that is not going to be diatomic. All right, number 3, what types of elements tend to combine to form molecular compounds? All right, so I've already mentioned this. I mentioned this in the first problem, but the elements that we're dealing with in this chapter that make molecular or covalent compounds are non-metals only, okay? So the types of elements that tend to combine to form molecular compounds are, oh, did not mean to do that, sorry, are non-metals, okay? Non-metals only. Very important thing to remember. All right, number 4, what information does a molecule's molecular structure give? I think this is also be worded to be molecular formula, okay? But basically, a molecular formula or molecular structure gives you 2 pieces of information. 1, what elements are present in the molecule, okay? So it tells you what elements you have, 1. 2, it tells you how many atoms of that element are in the compound as well. So how many atoms of each element are present in the molecule. Okay, so it tells you what elements you have and how many. All right, last question, number 5. How do ionic compounds and molecular compounds differ in their relative melting and boiling points? Okay, so in this chapter, what was talked about primarily in terms of this was the fact that ionic compounds, usually are made of ions, and ions are very tightly bonded together, and they can't really go anywhere, okay, because they're usually in what's called a crystal lattice, where the ions are kind of stuck in place, which means that they are solids a lot of the time, and they have very high melting points and boiling points because it takes energy to cause those ions to be able to move apart from each other or move around, right, or melt them into a liquid. Whereas molecular compounds are not stuck in place, okay? They're sort of individual molecules that sort of float around near each other, but because they are not stuck in place and they can move around, they are a lot more fluid, which means that they're usually already going to be liquids or gases at room temperature, which essentially then would tell you that their melting points are low and their boiling points are low because they've already melted into a liquid at room temperature, or they've already boiled into a gas. So we can say that ionic compounds typically have very high melting and boiling points compared to molecular compounds, which have lower melting and boiling points. All right. And there we go. That is it for this section of notes. So hopefully that makes sense. But as always, if you have any questions, feel free to reach out either through email, you can chat with me in class, or we can do some, one-on-one maybe over Google Meet. All right, guys, I'm Mr. B. That's it for this one. See you in the next one. Bye.